So we're back with problem 1.6 in Everaise. Let's do this. So a basketball is thrown directly upwards with VL when it reaches a maximum height, H max. A second basketball is thrown directly upwards with the same VL. At what height did it collide? Okay, so basically this is where reframing the problem comes into play, right? Because instead of just like thinking about, oh, it went up, like we can actually probably just get rid of this entire thing. Oh shoot, my bad. No, not that part. We'll get rid of this first sentence because it confused a lot of people. You can just say that the ball was initially at H max and there's another ball. So you just ignore like the first sentence and you can reframe the question like this, and it's a lot simpler, I think. I think in the book they use like a graph or something like that. Anyway, reframing the problem actually also comes into play during health class. That's what I learned last week. Let's go. See, school makes you smarter. I swear. All right, so yeah. So what is H max? What is the maximum height a ball can attain? When just thrown with a vertical velocity. And I'm pretty sure it's H equals to V O squared all over 2G. Yeah. I think this just comes from like Y equals like V O T minus 1/2 AT squared or GT squared, and then you just like plug in stuff for the time. Yeah, but you should memorize this as well as like R equals VO squared sine 2 theta all over G. That's the range formula. I think. It's like how, if you throw it at this velocity and this angle, how far will it go? Anyway, shoot, why am I erasing this? Um, yeah, we could say the ball, it starts at VO squared all over 2G, right? Because remember in this equation, it's delta Y. So Y final equals to Y initial plus blah 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 blah. So that's going to be our Y initial. Nice. Okay. So we're going to say Y final equals to VO um VO squared all over 2G minus 1/2 GT squared. So look, like from this equation, you'll notice there's no velocity term. And the reason why it is because at the maximum height, like think about it, there's a ball and it goes up and it goes down. Here at literally the peak, V equals 0. It's, there's only one vector going down, and that's gravity. But gravity is always going down. All right. So, yeah, that's going to be the equation for this ball. And for this ball, YF equals to VOT minus 1/2 GT squared. Yeah, so basically, the first thing I want to emphasize, if this wasn't, I don't think it was very clear in the other videos, this is a full formula. The final position of the ball equals to the initial position of the ball plus VOT plus 1/2 AT squared. This is a full formula. Sometimes I just write y equals like blah 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 blah. Like just ignore this term, but this term does exist. When I write y, I mean like delta y. And the reason why I don't always emphasize that is because most of the time you'll be starting from like y initial equals to 0. Like for this one, for the ball that's released from the ground, y initial equals 0 because it's literally a 0. But for this one, it is at a y initial. It has an initial position. So I just need to emphasize that. So sorry if that like confused really anyone. Yeah, I'll be happy to take any comments, like any like questions in the comments. I just want to help people out, honestly. So yeah. Yeah, basically what we do here is just kind of set them equal. 1/2 uh, GT squared minus. Wait, I can just save myself some time real quick. Bang. See, intellectual. You know what I'm saying? V O T minus 1/2 GT squared. Okay, so first thing, these terms cancel out, right? 'Cause think about it. I put it over there. Negative 1 half GT squared plus 1 half GT squared. So VO squared. So VO squared over 2G equals VOT. And then we'll divide, right? I think VO all over 2G equals to the time. And our problem is not solved yet because in the end it's asking what height does it collide. Okay, so we have the time, and now we just plug it into one of these equations. Yeah, so let's just take this one. Let's just hold up. Let's just use this one. I'm gonna move it down. Bang. Whatever. So yeah, just plug it in, literally. That's it. So V O squared all over. I forgot the one here. Or I left it. My bad. 1 half G. What is that white speck? Am I tripping? I don't know. Whatever. V O squared all over 4G squared. Yeah. So V O squared all over 2G minus 1 half. Oh, sorry. I was meant to evaluate this term. The G's cancel here, right? And this is just left with 1G. 1 half VO squared all over 4G. So what are we left with? VO squared all over 2G. That's a 2, I swear. Okay, I'll fix that real quick. 2G. And you subtract, what is that? 1/8? VO squared all over 8G. And I think if you do 4, 8, 3VO squared all over 8G. Alright, so that is my solution. This is like the only way I'll ever do this question. Cause in the book, they make you like do some graphing thing. I don't know. I really do not get it actually. So yeah. So people that are struggling, I got you. Ref so in the end, reframe the question, figure out your variables, make the question into like equations. That's the most important thing. Can you convert words into math? And then yeah, just compute, and that's mostly solvable, all of them. But I do want to emphasize reframe the question is like one of like the most like goated techniques ever. Yeah, you gotta learn that. Not just for phys, just for life too. That's what health told me. Oh God. So yeah, yeah. Thanks for watching. Hope you enjoyed it. If you have any questions, I'll be happy to take them in the comments. Yeah, all right, thanks.